No, she's not, Sandy.
I mean-
She's like a 60.
Yeah, but she's gonna give us a texture.
You said
That's
60
correct.
would make him a great.
No, I'm not, Sammy. No, I'm not.
All
right.
So she's out.
Everybody good? 5 and 9.
I mean, I could never.
That was not it.
All right. Shh, guys. All right. So the first way is the old way that we did it. So when we learned limits to begin with, we had 5x squared minus 3x plus 1 over 3x squared minus 5. So the old way of doing limits, we divided everything by the highest power on the bottom. So we would do 5x squared over x squared minus 3x over x squared plus 1 over x squared. 3x squared over x squared minus 5 over x squared. Okay. Simplify everything you can. This will turn into just 3 over x. When you take the limit as it approaches infinity, anything 1 over x, 3 over x, 1 over x squared, they all go to 0. So you have 5 minus 0 plus 0 over 3 minus 0, or 5/3.
Wait, you said what happens?
Hold on, sorry. What happens as we go to infinity? To the right, where does our blue line go? 0.
Oh,
It doesn't matter what we have. If I change this to 3, what's gonna happen every time? So anything over x or over x squared is gonna do that. If it's over just x, it's gonna look the same as we go to infinity.
Okay.
Got it?
Yeah.
So that's why they turn into 0.
right, so infinity is 0.
Okay, as we move to infinity, where that's to the right, where does this graph go? 0. That's all you do.
Isn't it always? Why do you just walk in here like we aren't in the middle of class? But you need to go that fast.
She's not.
Hey, it's not gonna be a good morning for you. Ethan Clark will not leave Mr. Griffin's class. Yes, ma'am. Thanks, but
Just swing on it right now, just swing on it.
Yeah,
What if
leave the door open.
You got a bat back there.
What were you thinking about? It's all right, here, it's okay.
Y'all want to see what dealing with kids? Can you see it?
Should've just swung on it.
Like, it'll take a while for that to go away too. So look,
See, I thought it'd be a huge drive.
you're on.
The counting's not that bad.
All right, the new way. The new way, what do we do? Find the derivative. What's the derivative of 5x squared? Keep going on the bottom. Okay. When we put this in our calculator, you're gonna have an indeterminate form because 10x minus 3 is what kind of graph? a linear. So as we go to infinity, where does that graph go to? What about this one? It's also linear. So it's another indeterminate form. So we're going to keep going and take that derivative again, and we get, which reduces to any questions?
So if you have two linear equations for top and bottom, it'll be
Yes, because when you try to go to infinity, that graph doesn't go to a specific point. So the last one that we had when we were looking at it, it went down to 0, right?
Yeah.
Okay, so when we do linears, they just keep going up forever and ever and ever. So there is no specific point that it stops at.
So if you have a linear equation, that's for.
Mhm. All right, so there's number 9. What about 11? 11 was pretty simple. 15? 15? We can clean this up a little bit by distributing the negative. And then, what can we do? Take the derivative. So what's the derivative? I'm gonna go e to the x minus 1 over. So this will also be an indeterminate form. If we're looking at 3x squared, as we go 0 to the right, it's going to be 0. So that puts that 0 on the bottom, e to the x. As we go to 0 from the right, it goes to 0. So there's your other indeterminate form. Did everybody see that? All right, so what do we do now? Derivative again, which is? And then what's happening here as we go 0 to the right? All right. Nope. So this graph is a little bit misleading, So on our calculator, it looks like it stops on the x-axis. I mean, on the y-axis, it does not. Okay, so when we go into our table, I'm going to ask 0 to the right. So what numbers would be getting me close to 0 without touching it to the right? You know how we did the table in our notes, that one table, and then we did it a lot when we did limits. So we had the negative side of 0, and it was like 0.09, 0.099, or whatever. You guys remember that? Well, this one is coming from the right, so I got to stay in the positive. So that's the big thing. And then just put in some values. So let's go even further away. I mean, even closer. So every time I add a 0, what's happening to the number? A lot bigger, right? So the closer I get to 0, where is it going? Infinity. Does everybody see that? So this one I had to revert back to the table only because your graph is a little bit misleading. All right, 21. Everybody good with that one? Yeah. 25. Everybody's good with 25? And then 31. All right, so when we graph this cosine x over x, this is what it looks like. So what is this graph gonna do? What does a cosine graph do anyway? Yeah, so it fluctuates, right? So this is gonna do the same thing, but by this one is the squeeze theorem. So if you remember that. Where does this one fluctuate through? There is absolutely no work to do with that. And we'll review a squeeze theorem and all of that stuff. So don't stress out if you didn't understand what that was. All right, what about 35? Everybody good with that one? 39. You need 39? I didn't hear you, I'm sorry. Yes, okay. The limit as x approaches infinity, note 0. Of arc tan over sine. All right, so your derivative for arctan. Hello. Now you know why I posted that.
Okay, that one's more like that. Traffic is real bad.
See Tyler Road?
Thank you. All right. Find your derivative. So our u in arctan is actually x. So what is the derivative of x? Sorry, y'all. I swear there's 40 pieces of lead in here. There it goes. 1 over and then 1 plus x squared because our u is x. On the bottom, we're going to have cosine x. You could change it if you wanted to, but right now you can do direct substitution because cosine of 0 is 1. It's not 0, so that's why you can go ahead and do that direct substitution. If it ended up being 0, then you definitely wouldn't want to do that. So when I plug it in, I don't get an indeterminate form. I get 1 over 1 over 1, or just what? 1. Any questions? Everybody good? All right. So what you're going to work on is some more practice with L'Hopital's rule. There are 20 questions on here. We will go over it tomorrow as your review. You need to work on it today, not with me, with you. You need to work on it today. And then tomorrow we will go over them. And then what's tomorrow, Wednesday? And then Thursday you'll have your quiz. And if it runs into Friday, it runs into Friday. Got it? All right.